back to Daily Planet Goes North. I'm Kim Tiani.
And I'm Jay Ingram. You know, we're just on the outskirts of Iqaluit here, but when you're in the north, you're never very far from tundra. It is desolate, but it's beautiful, and nothing says north more than this.
But the big tundra could be in big trouble. We recently met an ecologist who's been tracking just how fast the tree line is approaching the tundra. This could completely change the ecology of the north.
There's a hostile takeover going on in Canada's north. A silent invader is surging up the mountains.
On the south-facing slope, we saw the advance uphill, clear and very distinct.
This scientist will take us to the front lines to investigate.
It's difficult, there's no doubt about it.
The stakes are huge.
Large areas of alpine habitat would be lost. Not just fragmented into smaller pieces, but lost completely.
He'll hike 2 hours, about 1,300 meters above sea level, before he comes face to face with the bully. Yep, a scraggly-looking tree. There's not just one, there are hundreds. What Ryan Danby is discovering here goes against conventional wisdom.
The typical thinking with Treeline is that trees at Treeline are so stressed that they produce very few seeds. An individual tree will actually send out a root that then turns into an individual tree, or a branch which actually hits the ground, gets buried in leaf litter and moss, and then slowly grows into its own tree. So it's literally a creep forward.
But these white spruce aren't creeping. They're aggressively advancing. A century ago, this plateau was covered by tundra.
The work in this region that I've done has uncovered a surge, if you will, or a leap forward in treeline elevation that occurred between 1925 and 1950.
Danby compares archival photos of south-facing mountain slopes with more recent images. The evidence speaks for itself.
The changes are really evident across this entire landscape. That tree line went up in elevation, but it's also evident that the density of these stands increased. So in the past, where there were sporadic trees, these stands have now become thicker. There's more trees.
Armed with this evidence, Danby wants to figure out how this is happening. He figures it takes two things: seeds and warm temperatures.
So you need those two parts of the equation to sort of come together in the right sequence of events, and then boom, something big happens on the landscape. You get a real fast, rapid change.
Danby wants to find out if there's a connection between soil temperature and the rapidly advancing tree line.
And so you just dig in.
To measure temperature trends, Danby's burying 100 miniature weather sensors.
And I've just attached these pink strings to the end of them so that when I bury them, I just have a piece of pink string sitting out above ground so that next year when I come back, I can find them.
We'll record temperatures every 6 hours.
And I give it a good kick for closure. Like that.
Danby also takes core samples so he can peek into the tree's history.
It's called the spoon, and this is the bit, and this is the handle. And the pieces together like this. Always have a little squirt of WD-40 on hand. And we want to core as close to the bottom of the tree as possible so that we get as accurate an age estimate on it. You can see the individual rings through here. 21, 22, 23, 24, 25, 26, 27. I put it in the 55 to 65-year-old age class, which means it's established during that period of upslope recruitment that we talked about in the 1940s, 1930s.
He wraps up the core sample in a drinking straw. He'll take it back to Edmonton for analysis.
And it's really interesting to see this. It's a little window into the past. We can actually reconstruct some climate variables, particularly temperature and precipitation, just from the width of the ring.
If Danby can discover what happened in the past, it'll help him predict what might happen in the future. If warm temperatures continue, so too could the surging tree line. That could be dire for tundra species. They'd be pushed higher up the mountain, they'd run out of space.
Right now you look across this valley and you see that tree line goes up here, but this ridge that's covered in clouds, you can't see it right now, but the ridge is connected. If Treeline was to move up and separate that ridge, then those ridges wouldn't be connected, and then we'd have two disjunct populations of alpine dwelling species. And then that has effects potentially on genetic structure of these populations in terms of inbreeding and these sorts of things.
It'll take more than Danby's lifetime to document this aggressive takeover. That's why he's taking digital photographs of trees and recording their location using GPS.
So that down the road, even if it's not me taking the second photograph or the future photograph, then somebody else can interpret those just as easily.
This is one frontline battle, or should I say treeline battle, that won't end anytime soon.
Stick around because right after the break, we're going to meet Nunavut's only high school robotics team.
That's right, and thanks to a lot of innovation and some amazing technology, they are a force to be reckoned with. Their amazing story is coming up right after the break.